Hello dear students, I am Ijaz here. I am from West Bengal and I have almost 5 years of teaching experience. In these 5 years, I helped lots of students to crack their entrance exam and fulfill their dreams. So today, guys, we will learn a very important topic of class 12 physics, that is nuclear physics. In the upcoming NEET examination, you can expect 1 or 2 questions from that part. Nuclear physics. Guys, as we know, all the objects are basically formed by huge number of tiny particles. These are called molecules. Just like this marker is formed by huge number of plastic molecules. On the other hand, this wood pencil is formed by huge number of wooden molecules. So all the objects are basically formed by huge number of molecules. And the molecules are also formed by tiny particles which are called atoms. And inside the atom, nucleus is present at the center of the atom and the electrons are revolving around the nucleus, just like that. This is just like that. This is an atom where the electrons are revolving around the nucleus, and this is nucleus. And the nucleus is formed by positively charged protons and uncharged neutrons. And togetherly the neutrons and protons inside the nucleus are called nucleons. And the nucleons are bound together by a very strong nuclear force. So one question arises from here, that what is nuclear force? Actually, nuclear force, the properties of nuclear force are that this is the strongest known force ever. It is a very short range force because it only acts in nuclear ranges. That means it acts in the range of approximate 10 to the power minus 15 meter. And number 2, according to the data of NCERT, nuclear force, it may be attractive, it may be repulsive. For distance greater than 0.8 femtometer, for distance greater than 0.8 femtometer, nuclear force is attractive in nature, and for distance less than 0.8 femtometer, nuclear force is repulsive in nature. And guys, 1 femtometer is equal to 10 to the power minus 15 meter. And the another property of nuclear force is this is charge independent. That is why it acts between positively charged protons and uncharged neutrons. Now we will see the expression of nuclear radius. Nuclear radius. Here we consider a nucleus having mass number A. We consider a nucleus having mass number A. The standard symbol of mass number is A, which is given by A is equal to N plus Z, where N is the number of neutrons and Z is the number of protons. So A is basically called the sum of number of neutrons and number of protons, or you can say that A is basically represent the number of nucleons. So here we consider a nucleus having mass number A, and we consider the radius of each nucleon is small r. The radius of each nucleon is small r and the radius of whole nucleus is capital R. So capital R is basically the radius of whole nucleus and small r is basically the radius of each nucleon. Now from the conservation of volume we can say that the total volume of the nucleons is equal to the volume of the nucleus. That means volume of each nucleon is 4/3 pi r cube and total volume of nucleons is A times 4/3 pi r cube. This is equal to 4/3 pi capital R cube, which is the volume of the nucleus. Now from both sides 4/3 pi will cancel out and we get A small r cube equal to capital R cube and capital R equal to A to the power 1/3 small r. And the value of small r is basically varies from 1.2 to 1.5 femtometer. And for the sake of simplicity, for calculation, we basically write this formula r equal to r0 a to the power 1/3, where r0 is constant and we choose the value of r0 equal to 1.3 femtometer. So this is the expression for nuclear radius. And and the value of R0 is 1.3 femtometer. So that's all for today, guys. Thank you.